This video explains part 1 of chapter 9, section 3, a change in temperature. I have a question. Why the temperature of seawater is lower than that of the beach in a hot summer day? If you touch the beach, the sand of the beach, it will be hot, while seawater is cooler than the sand of the beach. Why? The answer of this question will be clear after discussing the following items. We mentioned before that when an object gains a quantity of heat, its temperature will increase. Its temperature increases. While when an object loses a quantity of heat, its temperature decreases. So the change in temperature depends on heat, amount of heat gained or lost. Now, you have two objects of the same material of iron, for example, each of 2 kilograms. The first object is heated from 15 degrees Celsius to 50 degrees Celsius. So the change in temperature equals 35 degrees Celsius. While the second object is heated from 15 to 70. So the change in temperature equals 55 degrees Celsius. Which one of them needs a larger amount of heat to be heated? The first object or the second object? Here the change in temperature equals 35, and here the change of temperature 55 is heated more. So it requires a larger amount of heat. So the amount of heat depends on the change in temperature. Larger change in temperature needs larger amount of heat. So Q depends on delta T, directly proportional. Larger change in temperature, larger amount or quantity of heat. Another example. 2 kilograms and 5 kilograms of the same material. They are heated from 15 to 50, the first object. Delta T here equals 35. And also here from 15 to 50, delta T equals also 35. The same interval of temperature, the same change in temperature. But they are different in mass, 2 kilograms and 5 kilograms. Which one needs a larger amount of heat? The first or the second? You have a cup of water and a larger container of water. Which one needs a larger amount of heat, will be heated for a longer time? Of course, the 5 kilogram. Larger mass needs a larger amount of heat. So Q directly proportional with the mass, M. So Q directly proportional with M. Now, you have two objects. One is made of iron, and the second is made of copper, each of mass 2 kilograms. And they are heated through the same interval of temperature. Delta T equals 35. And here also delta T equals 35 degrees Celsius. The amount of heat gained by iron will be equal to the amount of heat gained by copper? No. Here, though they are heated through the same interval of temperature or the same change in temperature, and they have the same masses, but the amount of heat depends on the material itself, depends on matter. So here we have C, which is called specific heat or specific heat capacity. And this quantity depends on the material itself. So we have Q depends on change in temperature. Q depends on the mass, and Q depends on specific heat capacity. So Q equals M, mass, specific heat capacity, and change in temperature. So Q, quantity of heat, equals M, C, delta T. So let's discuss an example. Calculate the quantity of heat. What's required here? Q. Required to raise the temperature of 10 kilograms mass of a substance from 30 degrees to 70 degrees Celsius. If you know that the specific heat of this material equals 400 joule per kilogram Kelvin. Think about. So Q equals M C delta T. Q equals, the mass equals 10 kilograms. Specific heat is given to be 400. And the change in temperature is 70 minus 30. So it will be 10 times 400 times 40, the difference in temperature, equals 16,000 joule, 160,000 joule. Okay, clear? Okay. Now, Q equals MC delta T. So C equals Q over C over M delta T. Specific heat equals M delta T. So let's define the specific heat capacity. It's the quantity of heat required, the quantity of heat energy, the heat or energy required to raise what? Change the temperature. Change the temperature of, what's the amount of material here? Quantity. There is a temperature of 1 kilogram. Raise the temperature by 1 degree Celsius. So specific heat capacity, it's the quantity of heat required to raise the temperature to increase the temperature of 1 kilogram by 1 degree Celsius. The specific heat capacity depends only on type of material. The specific heat of iron is different from the specific heat of copper, is different from the specific heat of aluminum, is different from the specific heat of water. The specific heat of water equals 4,000, it equals 4,200 joule per kilogram Kelvin. And it is the highest specific heat of any material. So water has the highest specific heat, which is equal to 4,200. Means what? What's meant by the specific heat of water equals 4,200 joule per kilogram. If you have 1 kilogram of water and you need to raise its temperature by only 1 degree, for example from 20 to 21, this amount, the 1 kilogram, will take 4,200 joule to increase its temperature by only 1 degree Celsius. Clear? This tool is used in determining the specific heat and is called calorimeter. Calorimeter is used to measure or determine specific heat capacity of materials. And it consists of 2 containers, larger container and smaller container, are placed inside each other with an insulation material between them. And here is a stirrer to mix the materials with each other. And here is a thermometer to measure the temperature change. And calorimetry is a procedure, experimental procedure, used to measure energy transferred from one substance to another substance. We use the calorimetry, the procedure itself, to measure energy transfer from one object to another. By what amount is called calorimetry. If you have a cold object and a hot object, they are placed in thermal contact. They put with each other. We notice that the amount of heat gained by the cold object equals the amount of heat lost by the hot object. For example, if the hot object loses 1,000 joule, the cold object will gain the 1,000 joule. Okay, neglecting any loss to the surrounding. So, the amount of heat lost gained equals the amount of heat lost with a negative sign, because this amount of heat is lost and this amount of heat is gained. Here increase and here decrease. The mass of the cold object is M1 and its specific heat equals C1 and its temperature is T1. The mass of the hot object M2, its specific heat C2, and its temperature equal T2. After mixing them together, the temperature of the hot object decreases and the temperature of the cold object decreases till they reach thermal equilibrium or the same temperature, which is called T final or TF. So now, quantity of heat gained equals M1 C1 delta T1, and the quantity of heat lost equals M2 C2 delta T2. Okay? So, M1 C1 and delta T1 equals TF minus T1 equals minus M2 C2, and the change in temperature delta T2 equals TF minus T2. Okay, this is the rule or the formula which we will use to solve the calorimetry calculations. Okay, M1 C1, the mass of the first object or the colder object, its specific heat and its change in temperature equals M2, the mass of the second object, mass, specific heat, and the change in temperature. This represents delta T. Here, mass of the hot object, of the second object, and its specific heat, and its change in temperature. Let's discuss an example. .7 kilogram of a material, of a metal, is heated to 90 degrees Celsius, is dropped in 1.8 kilogram of water at 25 degrees Celsius. The final temperature of the mix equals 30 after mixing them together. Find the specific heat capacity of the metal. You know that the specific heat of water equals 4,200 joule per kilogram Kelvin. You have 1 minute to solve this problem. You can pause the video and play it after finish solving. So, .7 kilogram of a metal, M2, is heated to 90 degrees Celsius, T2, then dropped in 1.8 kilogram of water, M1, at 25 degrees Celsius, T1, as it is the cold object. The final temperature is 30, TF. Find the specific heat of the metal, C2. Specific heat of water, C1. So, M1 equals 1.8 kilogram. C1, this is the water and this is the metal. C1 equal 4,200 and T1 equal 25 degrees Celsius. Mass M2 equals 0.7 kilogram. C2 unknown and T2 equals 90 degrees Celsius. And the final temperature TF equals 30 degrees Celsius. So M1 1.8 times C1 4,200 TF 30 minus 25 TF minus T1 equals negative M2 0.7 C2 unknown and T2 TF 30 minus T2 90. So 1.8 4200 5, the change in temperature equals minus 0.7 C2 minus 60. So after calculating okay, 1.8 times 4,200 times 5 equals 37800 equals 0.7 times 60 equals 42. 42 C2 divided 42 divided 42 C2 equals 900 joule per kilogram Kelvin, and this is a specific heat of the metal. Thanks for watching till we meet in part 2.